I'm Zarin. Today, me and my group members Soban, Harris, and Umar will be doing a slingshot project. Is to find out our constant, which is K, and also how the law of conservation of energy is implied when doing this project.
Before we start, here's a clip of our experiment.
So now we'll be doing the calculations to solve the spring constant. So in order to do that, we will be using the law of conservation equation, E total initial equals E total final. And the reason we are doing this is because that there is stored elastic potential energy inside the slingshot, and then when we release it, then it transforms into kinetic energy. So right here is the formulas, Eg plus Ee plus Ek. And these are the variables, all of the variables. So the mass we know of the beanbag is 0.1 kilograms. As we know, gravity is 9.81 meters per second squared, and the height that we were as said before, it was dropped negative 1.2 meters. The stretch was 0.92 meters, and the way we got this was from subtracting the slingshot that wasn't stretched from when it was stretched, and from there we got 0.92 meters. Alright, so when we sub in we will just put all these variables inside this formula, and so right here, just pause the video if you just want to pause, and we'll keep going. And then after, when we put in all of our variables inside the formula, we rearrange for K, which is right here, and we factor out the mass out of the right side of the formula, so it will be 0.1 of a bracket v squared minus 9.1 all over 2. So then once we solve that, we solve our calculations, and we get 7.46k equals v squared minus 9.81. So we're trying to solve for the spring constant is, and we also have to know what v is. So now we'll be figuring out what our v was throughout the projectile. Alright, so when we're solving for velocity, we have to understand that there are going to be components in the x direction and in the y direction. So we'll start with the y direction component of the velocity, and so we know our time that lasted was 2.32 seconds, and the height that was dropped was negative 1.2 meters. So this is our formula for Vy squared, and Vy squared equals to Viy squared plus 2ad. The reason we're crossing out the velocity, initial velocity, is because the v initial is 0. So once we put our variables in, we get 4.84 meters per second for the y direction of the velocity. And then on to the x direction of velocity, our distance of the slingshot traveled was 15.69 meters, and that is over 2.32 meters. So once we do that, we get 6.7 meters per second as our velocity in the x direction. So we use components, we use a Pythagorean theorem to solve our velocity, and from there we got 8.31 meters per second. Back to the other page right here, we're still trying to solve for k. Since now we solve what a v is right here, now we just sub it in and we solve for k, and we clean it up, the formula, and we get 7.95 as our spring constant.
In our calculations, we neglected air resistance due to the fact that the mathematics would be quite difficult if you take into consideration the object and the wind and the specific vector that it was blowing in against. And basically, for our experiment, the wind was going against the beanbag. So if we encountered air resistance, the K or spring constant would actually be lower than expected, and vice versa. If the wind was going with the beanbag, the K constant would actually be greater. And in addition, in our case, since the wind opposed the beanbag, it would actually cause the K constant to be lower, because the distance that the beanbag would travel forward would decrease, and in turn, inputting that into the formula would give you a lower K value, and would also in turn, since the velocity would be lower, the kinetic energy would be lower, also decreasing the total energy of the system. friction also affects our calculations since friction does negative work on the object. The kinetic energy decreases and becomes less than the potential energy, and therefore causing the calculated spring constant to become lower than the actual amount calculated by us.